Alright, ladies and gentlemen, this is going to be the next video on diffusion and selective permeability. So let's get started on this next video. So I want to think about 4 spheres in a box. Now, these spheres are going to be representative of gas particles here. And if we were to let these spheres go through and randomly move on their own, they're going to move away as far apart from each other as they possibly can. Now, we refer to this process in chemistry as diffusion, and diffusion is the net passive movement of particles, either atoms, ions, or molecules, from a region where they are in higher concentration to a region of lower concentration. That's all diffusion is, and it's a state of nature, and it's what particles naturally want to go through and do. Now, I also want to think about the word selectively permeable. So selective permeability is a property of cellular membranes that only allows certain molecules to enter or exit the cell. So some molecules are going to be small enough that they can simply pass through the membrane. We're also going to have channels for molecules that are too large but are of the right shape and polarity to pass through. Now, if molecules are not of the right shape and polarity, they're not small enough to fit through, or they're not the right shape to fit through the protein channel, well, then they're not going to pass through the membrane. And that's what we're referring to when I say selectively permeable. We're being selective about what goes in and out of the membrane to regulate and maintain homeostasis in the cell. So I want to go through and talk about concentration gradient. And there's 2 scenarios that we're going to go through and look at. But concentration gradient is the process of particles, which are sometimes called solutes, which are moving through a solution or gas from an area of a higher number of particles to an area with a lower number of particles. So concentration gradient is going to look like this. If we are moving down the concentration gradient, well, in this case, let's say we have a box of these 4 molecules here, and it's not going to require energy. And if we were to look at this, we would see moving down the concentration gradient, well, the molecules are going to want to naturally go through and spread themselves out. Now, if we go to a different scenario, up the concentration gradient, well, it's going to look like this. We're going to go through and it's going to require energy because we're trying to put the molecules into a smaller space that they do not want to be in. So concentration gradient refers to how the molecules want to spread out. Naturally, on the left-hand side here, we can see them naturally wanting to spread out in that space. And on the right-hand side, if we're going against or up the concentration gradient, we're putting the molecules closer together. So I want to look at another example of here in diffusion. So let's say I have the same 4 molecules, and I have this 2-chambered box. If I go through and inject the molecules into the box in the center, well, they're naturally going to go through and spread out as far as they possibly can in the box on the left. Now let's say I break down the barrier in the middle. What do we think is going to happen? Well, they're going to go through and again spread out as far as they possibly can in that box. So once I've gotten rid of that barrier, they're going to go through and move amongst that box. So this is what I'm referring to when I go through and talk about the cell membrane in equilibrium. So if we're looking at this, let's say I have all of these molecules on the left-hand side. They can't pass through the membrane right now. So on the left-hand side of this selectively permeable barrier, they're going to stay as spread out as they possibly can. Now, all of a sudden, what I'm going to do is put in a gate that's going to allow them to pass through. Well, what's going to happen? Well, they're going to spread out as far apart as they possibly can in equilibrium amongst the both sides of the gate. So when I say equilibrium, well, equilibrium is achieved when the molecules have spread out as far apart from each other as they possibly can. And we can say that they have moved down their concentration gradient. So let's go through and look at this example. Let's say I have 4 molecules on the left, and then I have, it looks like 6 on the right. Now, normally the molecules are going to want to flow down their concentration gradient, but I don't want that to happen as the cell. I want all of the molecules, I need all of those molecules on the right-hand side of the cell for some function of an organelle. Well, what am I going to do as the cell? Naturally, the molecules want to flow to the left, but I have to pull them all to the right. What I'm going to do is use an active transport protein. I'm going to apply energy to that protein, and those proteins are going to go through and suck those molecules against the concentration gradient or against the way that they want to move. So if I'm moving molecules against the concentration gradient, what I'm doing is applying energy to get it to get there. So when this happens, I'm referring to moving the molecules as against the concentration gradient. Concentration gradient's normally this way, and I'm getting them to move the other way, and this is going to require energy. All right, so if we're looking at this image here, well, which way is down the concentration gradient? Or which way are the molecules naturally going to want to flow? Well, I look at the molecules here. I have 1, 2, 3, 4, 5 molecules over here. I have 1 molecule over here. Remember, they naturally want to go through and spread themselves out. So therefore, the concentration gradient is this way. This is down the concentration gradient. Now, if I were to say, what is up the concentration gradient? Well, up the concentration gradient would be going against the natural flow of these molecules. So this would be up the concentration gradient. And then if we were looking at it, this would be down our concentration gradient. So did you guys learn? Well, did you learn a couple of things? Did you learn what diffusion and selective permeability is? Did you learn what concentration gradient is? And did you learn how they play a role in energy with the cell? This is going to be the end of the video. I will see you guys in class tomorrow.